Okay, in this video we're going to look at a couple examples involving the chain rule. So here's a function, y equals, it's a square root function with a quotient inside. So that's a composite function because your inside function is a quotient and your outside function is a root. So the chain rule tells us that we take the derivative of the outside part, so that would be the square root. If it helps, write the square root as a, uh, a fraction exponent. That might help because that's sort of the rule we're applying. So the exponent will become the coefficient, and then the power goes down by 1. So negative 1/2. The inside stays the same. So the inside function, so we still have 2x minus 1 over x plus 1. Now we need to multiply that by the derivative of the inside, and the inside's a quotient, so we need to use the quotient rule for that. So the derivative of a quotient is the derivative of the numerator, so that's just 2 times the denominator, x, plus 1, minus the derivative of the denominator, which is just 1, times the numerator, which is 2x minus 1, all over the bottom squared. Okay, so that's the derivative. Now it's just a matter of simplifying it. So I'll leave the 1/2. First thing I would do is, this is a negative exponent, so I would flip the fraction and make it a positive exponent. So x plus 1, 2x minus 1, and that's all to the power of 1/2. The numerator here I would expand and simplify. So I'm going to have 2 times x, and then over here I'm going to have negative 1 times 2x. So actually, let's just write it all out. I was going to try doing it all at once, but I think it's easier if you just see it all written down. All right, now one thing, notice the numerator here and the denominator here are the same. So let's just write it like this. X plus 1 to the power of 1/2 and 2x minus 1 to the power of 1/2. And the reason I'm doing that is so that I can combine this one and this one. So x plus 1 squared. And now here the 2x and the minus 2x go away, and I'm just left with 3 on the numerator. So let's just take this 3 and combine it with the 1/2. So we're going to have 3 over 2. The numerator, so x plus 1 to the power of 1/2 on the top, and x plus 1 to the power of 2 on the bottom. So what I'm going to do is subtract exponents. So 1/2 minus 2 would be negative 3 over 2, or 3 over 2 would just be on the bottom. So I'm going to have x plus 1 to the power of 3 over 2, and then I'm going to have 2x minus 1 to the power of 1/2, and then there's just a 1 on the top. So that's it. I mean, you could change these fraction exponents. So let's say 3 over 2, and then that's a square root, 2x minus 1, and then this one is a square root, but cubed. And that would be the derivative. Okay, so here's a second example. We saw ones like this in the power of a function section, rule section, but you know, we can do it. We'll do it again here. These ones, the simplification is what made these hard. So this one's a product of two functions, so you have to take the derivative of the first function. 5 times 3x plus 1 to the power of 4 multiplied by the derivative of the inside. That's the chain rule portion. So times 3, and then you leave the second one. x cubed minus x plus 1 to the power of 4. So that's the first part of the product rule. Plus, the product rule says leave the second or the first function times the derivative of the second one, so the coefficient or the exponent becomes a coefficient. So 4 times x cubed minus x plus 1 to the power of 3 goes down by 1, and then multiply by the derivative of the inside, which is 3x squared minus 1. And that's the derivative, right? But we can obviously simplify that, I guess, a significant amount. So let's take these coefficients. Actually, what we'll do is we will factor. So what's common to this first part and the second part? In terms of constants, nothing's common, but we do have a 3x plus 1 to the power of 4 and a 3x plus 1 to the power of 5. So 3x plus 1 to the power of 4 would be the biggest common factor. And then from these two, we have x cubed minus x plus 1 to the power of 4 and x cubed minus x plus 1 to the power of 3. So x cubed minus x plus 1 to the power of 3 would be the largest common factor. So what's left over? Well, I still have the 5 and the 3, so that's 15. And I have an x cubed x cubed minus x plus 1 to the power of 1, and then plus what's left over from this bracket. Well, the 4 is left over. I have a 3x plus 1 to the power of 1 left over, and I have 3x squared minus 1 left over. So that's that, and then I just need to simplify that last bracket. Okay, so now I can just expand here. So I'm going to have 15x cubed minus 15x plus 15. And then if I expand this, I'll multiply this. So 3x times 3x squared is 9x cubed. And then I have to multiply by the 4. So that'd be 36 x cubed. 3x times minus 1 would be negative 3x times minus 4. So that would be negative 12x. 1 times 3x squared times 4 would be positive 12x squared. And then 1 times minus 1 times a negative 4 is minus 4. So we got 3x plus 1 to the power of 4. X cubed minus x plus 1 to the power of 3. Collecting like terms, I have 15x cubed and 36x cubed, which if you add that together, that's 51x cubed. With squares, I got 12x squared, and that's the only x squared term. X terms, I have minus 15x and minus 12x, so that's minus 27x, and then constants 15 and minus 4, so that's plus 11. And that's the derivative, fully simplified, fully factored.